Alright, intersections of two planes. Lesson 3. How many ways can two planes interact? Well, there are three ways two planes can interact. Planes can interact by being parallel and coincident, so basically infinite number of solutions. Parallel and distinct, basically no solutions at all. They don't interact at all. And finally, intersect at a line. So they intersect at a straight line with an infinite amount of solutions. First, parallel and coincident. So basically, the normals of plane 1 and the normals of plane 2 are parallel. So basically, n1 is equal to a scalar multiple of n2. And k is equal to all real numbers. The same thing with d value, directional vector. d1 is equal to a scalar multiple of d2. Here's a diagram that explains how the normals are parallel. And as you can see, the directional vector is basically k times d2 is equal to d1. Here's a quick example. There's line 1 and line 2. And as you can see, the normals of line 1 is 1, 3, and negative 7, which is a scalar multiple of, n2 is a scalar multiple of n1. So when you multiply line 1's normal by 2, you would get line 2 is normal. Same case with the d value. When you multiply the d1, which is 4 by 2, you would get line 2's d value, which is 8. In this case, this would be a parallel and coincident. Second scenario, parallel and distinct planes. The normals are collinear. However, the planes do not intersect, meaning they do not have any solutions nor do they touch each other. The d values are not multiples of each other, meaning d1 cannot equal scalar multiples of d2. So basically that's a diagram of that example. As you can see, the normals are parallel, but the d values are not. Here's a quick example. The same line. However, the normals of line 1 is 1, 3, and negative 7, which satisfies the normal. Let me say that again. The normals of line 1 is 1, 3, and negative 7. And when you multiply 2 times line 1, you would get line 2's normals. However, the d values are different. When you have a k value multiplying by the first d value, you would not get d. Pause it.